my video.
Yay!
Great, awesome. Well, Manuk is on the second video because he's like, whoa, magic.
Hey, no, he wasn't filming. He actually
Okay.
wasn't filming.
All right.
Oh yeah.
Yeah, this is on the video.
Whoa.
Whoa, magic.
All right. So
Oh yeah, I'm on Nation.
So this is going to be a two-part lecture today. I'm going to actually teach one thing first, adding like terms, and then I'm going to teach solving multi-step equations. They're very much related, but this was really an important thing to cover before I did that. So we're going to do both, and it's not that hard. If I had 5 apples and somebody gave me 3 bananas, I then have 3 plus 5, 8 apples.
Yeah, you would.
No.
Yeah, you would.
No, because it says
Yeah, you would. Use the banana to apple transformerator.
Yeah, an apple transforming.
See, some of my students are quite adept at this stuff. They understand the realities of life, right? The apple transformificator, whatever you say. Okay.
You can't magically turn
Banana to applerator.
So right. So let me ask: are apples and bananas like terms?
Yes.
They're both
Yes.
fruits.
No, we're not. Well, they're both fruit. They're both fruit. So I could say I have now 8 pieces of fruit, right? But I can't say I have 8 bananas, and I can't say I have 8 apples. So I'm going to have to say that I have 5 apples and 3
well, you
bananas.
could say it just wouldn't be a true statement.
Isn't it kind of like, you have 8 like 8,
So with algebra, the way this works in algebra is instead of bananas and apples, we're going to talk variables or no variables.
Variables.
Variables would be like X, Y, Z, A, B, C, D, M, N, L, O, P, all those things, right?
P, U, V,
Yeah.
W, X, Y, Z.
Variables. Oh, that's what you should. Variables.
Variables.
Yes, that's good. Okay. 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 So let's just talk about. Let's try this for a second. If I had 4 plus 5, are those like terms?
Yes. Yes.
No.
You sure?
Yeah. They're both numbers, but say like if you put an X behind the 4 and a Y after the 5, then they wouldn't be like terms.
Or even
if you just put an X after the 4, they
All right. So these are like terms because all that is the number. Okay, that's the number 4. That's the number 5. You guys have been adding these forever, right? For like at least
You've been friends
8
for
years.
so long.
You've been friends for so long, right? 4 plus 5 is 9. You can actually combine them. Oops. Interesting, 9, but okay. So, but now, what if I did this? 4x plus 5x. Now, can I combine those? Are those like terms?
Yeah. Yes, they are. Yes. Yes.
As long as they both have the same variable in it, then yes, they are. What this means is I have 4 x's plus 5 x's. This means, hang on 1 second, Sam, I'll call you in just 1 second. 4x means this, x plus x plus x plus x. That's what 4x means. It just means, how do I do this? Like that? It just, 4x means 4 x's. It means x plus x plus x plus x, right? Plus 5 x's, oh dear, x plus x plus x plus x plus x, right? So that is 5 x's. So how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 x's. So do you guys remember what this number is in front of the variable? What's it called?
What's a number?
The
Coefficient.
Coefficient, right. It is, I'll write it again. Coefficient, right? So when you have like terms, you can add the coefficients, the 4 and the 5, to a 9, and then it's not x squared because I'm adding. It's just x. I'm adding 4x plus 5x, it's 9x. I add the coefficients and just keep the variable x, right? It will never be it will never be x squared when you're adding, you know, x's,
But
right?
if you had,
If you
like,
were
an
multiplying,
exponent
if
there.
you were multiplying, yeah, if I put 4x squared and plus 5x squared, the answer would be 9x squared.
It just
Okay?
stays
Don't worry about the exponents right now, because some of you probably haven't studied exponents. You will understand them, you know, as we move into them. But regardless, those are like terms because the variable is exactly the same. It's an x squared. It's an x squared in this case. An s, so therefore x squared is my
So
answer.
like basically like terms are numbers that like they have the same kind of unit, kind of. Like,
Mm-hmm. Exactly. So yes, Sam, go ahead.
So you would keep the variable when you get your answer.
Keep the variable when you get your what?
Answer.
Answer, yes, exactly. Because look, that all, okay, let me get rid of the squareds again. Go back to where I originally was, because that's what I have here. So 4x's, all that means is x plus x plus x plus x. 5x's means x plus x plus whatever, 5 times, right? And then, so you add them all together, you have 9 of them. 9 of the x's. What does of mean in math? Multiply. Whenever you see the word of in math, it means multiply, right? So I have 9 of the x's, 9 times x. Does that make sense? All right? So now, what about this? What if I gave you this? 4x plus 5. How would I combine those?
By destroying the 4. Nobody likes 4. No, by destroying the x.
Okay,
Nobody likes
Bella,
x.
hang on.
So you divide each side by 4.
What, what do you mean
not
each side?
sides.
there has to
Where is
be,
there?
like,
Where are their sides?
there's no equal
Right?
signs, you can't
An
do it.
equal sign gives you sides, right? But there's no equal sign. Therefore, this is called not an equation, but a
Statement.
no
A
Expression.
state law.
Okay, expression. It's called. Remember that? It's called an expression. It's a mathematical expression. Now,
Expression.
are these like terms? Are these like terms? Absolutely not. This says I have 4 x's, and this says I have the number 5. Totally different. That just tells me the number of x's I have. This tells me I have the number 5. They're not like terms. I cannot combine them. I will have to keep them just like that. So if I had a problem that said simplify, right? If it said simplify this, well, my answer would be this. There we go. It's already simplified. There's nothing I can do. Whereas if I were asked to simplify this one, I could combine them. I can combine like terms, right? I can combine like terms.
Can
But I
you though?
can't combine them if they're not like terms. I can't combine them. I just have to keep them separate. Right? Does that make sense? All right. So what if I did this?
Well, you just added another side, so you could just throw the 4 instead.
Now, where was I going though? Okay. What if I did this? What if I said this? We'll use different numbers. I'm ready for another number.
Where were you going?
6x plus 8y.
No.
So that would give me what? What's 6 plus 8?
No, it will be 14, but incompatible.
Would it be 14xy?
Not incompatible.
It would be, I know that.
Wait, what does xy mean? X, what's the operation between x and y?
Plus.
Multiply, right?
Okay.
Right here? Is there anything that says multiply here? Am I multiplying x times y? No. That can't possibly be the right answer, right? When I, okay? So,
6x plus 8y.
what's 6x will say y? They are not like terms. This is my apple and this is my pomegranate, right?
This is my apple and this is my pie.
Right? Okay, so I would just say it's 6x plus 8y. Now what about this one? What if I gave you this? 2x plus 4x minus 6y plus 12y. All right, John.
The answer would be 6x and
So you're
6y.
adding you're noticing that these are like terms, right?
Yeah.
So I can add my,
You can add 2 and 4x.
which are called the
They are the x's.
The-
Sorry,
The
the number.
exterminators.
co
my god.
I'm making you say it. Coefficients, right? Okay, add the coefficients, yes. So it'd be 6x. And then what do I do here?
And then you do,
Those are like terms, right?
yeah, you do negative 6y plus 12y, which would be 6y.
Right. When I see something like this, I think of it as 12, Bella, turn around. 12y minus 6y, 12 minus 6.
It's 6.
It's 6. So it's positive, right? You see how that's positive? So I say positive, I put a plus sign for my positive. 6y. That's my answer.
Oh yeah.
That's my simplified answer. That's what you said.
Why is
Right.
it 6y? Because you can add 6y plus 12y.
It's minus 6y.
Oh.
So it's 12y minus 6y, so it's going to be 6 positive 6y. So, right? Okay, simple, right? Pretty simple? Yes, Issa.
So would it be the same thing if you had, like, say, 2xx plus 4x squared
I meant 2x plus 4x squared. That's a great question.
Oh.
Would that be, are those like terms?
Yeah. Yeah, because.
So I have a yes here,
Yes, because.
a yes here.
X times x is x times x, and x squared is x.
Yeah, so x times x is the same as x squared.
What?
So you're right. This actually could be rewritten as x squared plus 4x squared. Now are they like terms? Yeah. So I can say, so what would be my final answer in this one?
Where'd you get the other x?
She asked about this. If I had xx, Issa asked this question. Is 2xx plus 4x squared a like term?
Well, where'd you get the extra x?
This one? From her. That she asked it.
No, I mean, where in the problem?
This is
The
not
problem
this.
just started.
I'm sorry, new problem. Sorry, new problem. Sorry. She just asked a question. She asked a question, so I just wrote down what she said. She wrote this. So yeah, so it would be 6x squareds, right? Right? If x squared was an apple, I have 2 of them, plus 4 apples, well 6 apples. 6x squareds, right?
And then once you find out.
Make sense? Okay.
They're squared
So,
apples.
Now let me just make sure. What if I gave you?
No, they are.
My apples aren't not circled in Minecraft.
Y'all
either.
do-
All right. What if I gave you this?
y'all
5
do math.
times 2x minus 4 minus 8x equals I don't know, 4x plus 1. What would I do? Yes. I would have to use, oh wait, I didn't mean to do this. I didn't mean to do an equal sign. Sorry. I'm not doing equals. Get rid of that. Sorry. So yeah, I'd have to do my distributive property. 5 times 2, parenthesis always needs times, right? 5 times 2 is 10, 10x. Minus 5 times 4 is 20. Minus 8x. Am I done?
No.
Okay,
Because
John.
now you can simplify. You can simplify minus 8x and 10x.
So these are the same thing, right? They're like terms, right? So I can go 10x minus 8x. What's 10x minus 8x?
2x.
2x. Now is that legal for me to skip the minus 20 for a second?
Yeah.
Are you sure?
Yeah.
Yeah. That's a property of algebra. We're going to talk about properties probably next week. But that's called the commutative property. Commute meaning move back and forth like our 8th graders do. Very slothfully or what's the word? Okay, so, all right, so 10x minus 8x is 2x, right? 2x minus 20. That's my answer. That would be my answer right there. Right? Good. All right, fist of 5 on adding and combining like terms.
How would that be your answer? Do you have to solve it?
Well, no, can't, no equal sign.
As long as there's no equal sign, you can't solve it. It's as soon as we put an equal sign and a value on the other side, then you can solve it. Yes. Question? Oh, you're just saying, you're stretching. You're saying yes. Okay, good. All right. So I'm going to move on now. Yes. Question?
So, it's about this. So if you have an expression, but a problem that doesn't have an equal sign on it, you can still simplify it.
You can still simplify it, but you cannot solve it. There's no way with this to know for sure what x equals, right? I just know that I can add 10x minus 8x is 2x minus 20, but I don't know. X might be 4. It's possible. It's possible. But I don't know, right? I really don't know. If it was 4, I could solve it, right? If I knew, if somebody said, let's evaluate. They might say, you might get a problem that says, evaluate this expression when x equals 4. Have you ever seen those kind of problems?
Yeah.
Evaluate, find the value of this expression when x is 4. So yes, Sam.
So without the equal sign, you cannot solve
Without the equal sign, you cannot solve
this problem.
it. Solving means telling me what x equals, right? That's what solving means. Yeah, right. But I can't say x is 4. X could be 5. There's even a chance it's 1,022,022, right? So it could be anything. So I don't know. So I can't solve it. I can just simplify it. Does that make sense? You see the difference between simplify and solve? Okay. So now we're going to go into the second part, which is solving multi-step equations. You guys are so ready to do this.
And solve.
Are we gonna do this in our homework?
I'm sorry, what?
Are we gonna have all this stuff in our homework tonight?
Yes. There's the first front page is combining like terms, and the back page is solving multi-step equations, okay? So now in solving multi-step equations, somebody tell me again, what is the definition of an equation? Well, how do we know something's an equation? Skylar.
It has an equal sign.
It has an equal sign. Well, okay, so it has an equal sign. It has to have an equal sign.
Expression, and it has an equal sign.
It has, okay, an expression, an equal sign, and then maybe something on the other side, right?
Number.
What a number, say, or it could be another expression possibly, right? So the question is, what does the equal sign mean?
Means equal.
It means.
Well, what does equal mean?
It means equal.
That side is equal to this side. The expression is equal to.
Wait. You are trying to tell me that the equal sign says this side is the same as this side.
Yes.
Oh, okay. That's what I thought you were saying.
No,
That makes sense. I think that's right. Oh my
Yeah.
God, that's right. Right?
Yeah,
So the weight, if I put 10 pounds over here and I had an equal sign and I had 5 pounds here, it wouldn't be in balance, would
You'll
it?
follow the equal sign would be.
Oh, I have to have 10 pounds here and 10 pounds here. Then we're
What
in
if you had
balance.
37 pounds on it?
So what's, when I say balance, what do I mean by balance?
I mean, it's balance skills.
What?
No.
Say it again.
Balance skills.
Scales.
Skills.
Brilliant idea!
Skills.
Oh my
Skills.
God.
Skills. Skills.
Like sneeze and laugh and like.
Okay.
Yes.
All right.
That was.
Okay. So I think you guys are saying that an equal sign, an equation, is the same as a balance scale, right? And so there's my equal sign, right? So Dee Dee, see this?
Oh my God, it's
Dee Dee?
beautiful.
See that? So there's my equal sign. Whatever I have on this side has to be the exact same thing on this side. So let's just try a few things.
We need to put more so it'll actually go on one side.
Okay, guess what this is?
Figure jaguar.
One.
It's variable.
This is a variable.
Oh.
All these years you've wondered what is really a variable. What does a real variable look like? This is it.
Three little cylinders.
This is a variable. Okay,
It's a square.
what is this?
It's a cylinder.
All right, now watch this. Shh. Okay, watch. Don't everybody move.
It's 5.
No.
So the variable.
It's totally balanced. Now my problem, I have this big problem. I'm trying to figure out what does this equal.
5 equals
Duh.
the variable. So.
Harry, it says 5 right there.
Oh,
and
right.
It has an
So,
equal sign.
5
in the middle,
equals
so like,
this. This
duh.
has to be 5, right? Oops, I went the wrong way. We'll try that again. Take two. Okay, I'll take that off, right? Oh my gosh! That's amazing, right? Okay, So you're right. So this must equal 5. Okay, so now let's make this a little harder. I'm going to put x plus 2 equals, we'll use a different number. We'll use 10. Ooh, x plus 2 equals 10.
Yeah, but how come the scale didn't
Now-
go down?
Now the thing is, I
scale's
have to
affected.
simplify this. Think about what you did last night in your
How
homework.
do you know it's plus
I have to,
not
s-
the multiply?
because there's no multiply. It's just plus. They're all pluses on this.
There's no multiply.
Okay? Good question. It's a good question. So we have an x plus. Let's actually write down what we have here. Let's just do. We've got it. You guys, it's a little noisy for me. Oh, Manu, are you writing this stuff down?
Yes.
Where are your notes?
Over here.
Adding like terms.
Very, very
Where are your
detailed.
notes?
Extremely
So
detailed.
these are not notes.
Okay.
I need your notes. Come on. So all that I put up there, come on, you gotta write stuff down. But x plus 2 equals 5, equals 10, excuse me, equals 10, right? Now, I want to simplify this. I want my x's all by themselves. In this case, there's only one x. I want my 1x all by itself. So what do I have to remove from this side to get my x? All right, the 2. So
You gotta divide both sides by 2.
now,
Then that 10 will become 5.
wait.
Oh, you have to
Subtract, right?
subtract.
This time I have an 8. All right, so I think I got it. I'm a little cramped here. Okay, here we go. I'm going to change the 10 into a 2 plus 8. Is that okay? Is that legal? All right, so now that I've done that, I could take my 2 off from this side. If I took it off just from this side, would that be a problem?
Yes.
Right? It would, right? Then now suddenly everything, whoa, I don't want to do that, right? So I'm going to have to take them off at the exact same time. Exact same time. Okay, oh my God!
Oh my god, you did it, Gary.
I figured out x is equal to,
8. Whoa.
all right, so what I just did, is I took away 2 from both sides, and that gave me x is equal to 8. All right, now, sorry, oh yeah. No, I have special powers that make it stay there until I'm done, okay? Just so you know.
What? No, you can't have 3 variables. That's illegal. Gary's cheating.
Wait, are the variables all variables?
I like variables.
I like variables better.
I know, everybody likes variables.
Are they variables? I'm children's cereal.
Okay, you're good. Well, today.
Are they those?
All right.
You're shipped to it all.
At Starbucks.
All right, so we now have an equation up here. Let's erase this one. Tell me what it is.
3x.
X to the third, no, X to the third power.
No, it's 3x.
No, it's not times or plus. X plus x plus x, which is 3 x's,
Oh, wait, right.
right?
3.
Plus 1
Plus 1.
equals x 2x plus 8 equals 97.
Okay. Okay. Shh. Okay. All right.
Wait, but Gary, don't you have X, X, X?
Which is x to the third power.
But it's adding.
But it's all adding. That was your question before. You only are adding this, right? Okay. You're not multiplying. You're not multiplying. Okay, shh. Guys, it's a wee bit noisy for me. We've only got like 7 minutes, 8 minutes, so I really want to try to focus for a second. Now, the golden rule of algebra says, I want to simplify this, right? And the golden rule, there's a problem. First of all, what do you see as a problem here? That's different than,
Aren't the same on either
Too many X's.
numbers are different on both sides, but there's another big serious problem. Really serious problem.
Already multiplied your X.
Wait, I gotta raise your hand if you're gonna talk.
Variables on both sides.
There's variables on both sides of the equal sign. I have never done that to you before. No. Ever. But today, I
Nate
am.
did.
So, he did?
Yeah.
Oh, he did? Okay, great. So, perfect. But,
But
so the golden rule says whatever I do to one side, I have to do the other. So is it legal for me to take one of each away?
Yes.
Oh my God, that's amazing. Look at that, how much that simplified my board.
So that, couldn't you take one more away?
Oh my God, there's still one on both. Okay, I could take, oh my God, it's still in balance.
No.
It's unbelievable. Now, please tell me I have a 7 in here somewhere.
So x equals 7?
Wait. I'm gonna change my 8 to 7 and 1. Is that legal? 7 plus 1. So now, if I take my 1's away,
x equals 7.
x equals 7.
No.
Isn't that amazing?
That's crazy.
Wait, I need to write this down. This is confusing. 22
So
equals 2.
let's go back. So let's do it one more time, but we're gonna do it slightly differently.
Oh my God!
So guys, it's too noisy, please.
It's crazy.
It's too noisy. I know we're having fun, but just keep it down, okay? Hang on one second. So this was our problem, right? This was an 8, but I'm gonna change it to 1 plus 7. Is that okay? Okay? So we just took 1x away and then 1x away from both sides. Could I do it in one move?
Yeah.
Could I take 2 away from this side and 2 away from this side?
Yes.
I could. Could I take 3 away from this side and 3 away from this side?
If there was
No.
3.
Not really, if I want to deal with positive numbers. I technically could in math, and then I'd have negative x's, right? Well, you will end up doing it because you'll probably choose to do it yourself sometime, and then you'll have to know how to do it. But don't worry, we'll get there. But right now, we always choose the one that has the smaller number of x's, right? So I'm going to take 2 away from the side and 2 away from the side. Don't breathe. Oh my God, it worked.
God.
And I'm going to take the 1's away, and I now know x is equal to 7. So what did we do algebraically? We subtracted the smaller number of x's from both sides. That's a positive 2 x's right there, right? So to move this to the other side, I'm actually going to take it away. I'm going to subtract it. Subtract 2x from here, and I don't put it underneath the 1. I put it underneath its like term, 3x, right? So I'm going to put minus 2x here, draw my line, and then I have x plus 1 is equal to 8, right? In this case, it was 7 plus 1, right? But now, I want my, I'm sorry? Right, right, this was the final answer. This is set up at the final answer. We're not at the final answer until it says x equals. The plus 1 is in the way, right? So we now have to get rid of that 1. So whatever sign is in front of the 1, it's going to be the opposite sign here. So it's going to be minus 1, minus 1. I put it right underneath the 8 because those are like terms, right? And so now I have x is equal to 7. Piece of cake, right? Piece of cake. And it works, right? Now, sometimes you'll see this. You'll see a problem. Can I erase this?
Maybe. Yes.
All right. Last one. This is my last one because I'm running out of time. Let's say I gave you this. This problem, 2 times x plus 4 equals x minus 2. I don't know, something like that. Well, actually, let's do x plus 2. Right? I don't have an easy system to make minuses on this thing. I've thought about, it takes time. I was thinking like a hot air balloon attached to the numbers, right? Because the hot air balloon means it's lifting it off, right? But I haven't taken the time to do it. So it's easier to just, that's possible.
And like put Velcro on it.
It's an interesting idea. I don't know. Yeah. Well, anyways, let's talk about that. All right. So now, what does this mean? I know that that's the distributive property if I did it mathematically, but what does that mean on this board? It says I have 2 of these. Of means time. 2 times. Parenthesis means times. Of means times. 2 times this or 2 of this. I have 2 of the x plus 4s. All right, so I'll get 2 x plus 4s. Here's an x plus 4, right?
How is it not dying?
And
Gary has magical powers.
an
No,
x. All right, that's me. I'm amazing. All right, and then over here I just have an x plus 2. That's easy. X plus 2. Come on, 2, 2, 2, 2.
That's not equal.
There we go.
Totally is equal. Gary told her to.
That says it's equal. It's got to be working. So how do I simplify this board?
Just take one and
Take 1 away. Beautiful. Okay. Now, let's see here. Let's change the 4 into a 2 and a 2.
Wait, how?
Oh, wait. Oh, that's a good point. I shouldn't have done that.
I'm confused.
That's okay. It's okay. Never mind. Yeah, that's okay. We'll keep it at 4. Now, what is 4 plus 4 here?
8.
Are those like terms? Can I simplify them? So find my 8. Here's my 8. Got to do it fast because you know how this thing's so tippy. You notice? Okay. Look at that. Oh my God. Okay. So yeah, you got to be really careful. And then now I got to get rid of 8 from both sides. Now, unfortunately, I didn't think about this, so now we're going to deal with negative numbers, right?
Do we have to
I'm
take
gonna
away 8? We can
take-
take away 2.
I'm going to take 8 away from here,
No,
and
no,
then
you can take away 2 and
how do I do this on a
Yeah.
board like this
Never mind.
You can
to
take
show?
8 away from there, which would just be 9.
All right, so this is going to be negative 6, right? If I take 8 away from here,
Yeah.
it's going to be negative 6. Negative 6. Negative 6. Oh, I know. Wait. Don't breathe. Wait, this thing. Wait, I gotta. Where's my
You just
6?
breathe.
Wait, where's my 6?
You
Come on.
breathe in. That counts as breathing.
All right, here we go.
Put a 0
We're gonna
in
do
the
our
six.
6
That's
upside
a
down.
9.
Okay, well, how about that?
Still a 9.
How about that?
Still
Okay, it's an upside down 6, right? Which means it's negative.
Put it on its side. You can put a 0 and then a 6.
Yes. But anyways, you got the idea, right? So we've got this. We could have just written this as x plus 4 plus x plus 4, or we could have done the distributive property and written it as 2x plus 8 is equal to x plus 2. We took our smaller number of x's and we moved them to the other side. We subtracted them. I'm going to subtract x. Subtract x. Boom. So that gives me 2 x's minus 1x is x. X plus 8 equals, those cross out, right? So then 2. And then I want to say x equals. So I'm going to get rid of the 8. Get rid of the 8. Draw my line. X is equal to negative 6. Next time I won't do that with my
I'm
balance
confused.
scale. You're confused?
Yes, I did it a different way and I got the same answer, but like
Well, what
I
did
don't
you
know.
do?
I didn't finish
Yeah,
it.
I
What
did
did-
the
wait.
same thing.
Okay, what did you do?
I did like first if you have the regular problem,
Here?
just do minus x on both sides, and then
But see, now wait, the only thing is, she's got an interesting thought. She subtracted, he subtracted x. She subtracted x from this side. But is it legal to subtract an x
Yes.
from this now?
Yes.
no because there's
No,
2
because that x is busy being multiplied by 2.
Yeah, but
I
they
have
can
to,
just do it
remember
after.
PEMDAS says I have to do multiply before I do subtract.
But
So,
then you can just minus 1x and it'll still
No.
be an x.
no, so you have to
Oh.
multiply this out first. You always get rid of, that's a great question, you always get rid of your parentheses before you start simplifying, right? You always want to do your distributive property first. That's PEMDAS. That's doing your multiply before you start adding and subtracting this.
What I did is I added x to 4 equals 4x and times it by 2. Times.
Well, you can't add x to 4.
No, in the
Oh.
parentheses.
You did what again?
So I added x and 4 in the parentheses, and I times it by 2 and got 8x.
Yeah, but x plus 4 is not 4x.
Oh, okay.
Those are not like terms. They have to stay separate because x, that's 1x. That says I have 1x, and that says I have the number 4. You see how they're different? So,
Wait, then how would you do this?
so you do, forget this, you just do your distributive property, and you get this, and then you subtract your x's. First thing you always want to do is get your x's on the same side, and move the numbers around, okay?
I am too proud.
So homework is this.
We have break now.
Does that make sense? Guys, fist to 5, just so you know. Do you guys feel like you get it?
I'm at 4. I'm at 4. I don't really care.
My mom
Me
reads
too.
math though.
My dad is so.
My mom reads math.
When I go home and I ask my dad, what's 4 plus 4 is like, oh, and that's a way we use divide 4 by lot to draw it, and I'm like,
Dad, 4 plus 4 is 8.
You don't need all that. And he comes up with like this crazy, and then it's like 5 hours long. I'm like, Dad, please. 5 then, 10 again.
I'm like, that's what I'm supposed to find out. And she's like, well, I don't know, go ask your friend. I'm like, what? Where's his name?
He talks about the winter time.
Call your friend.
We gotta turn this off.
Serious.